Hello, everyone, and a very warm welcome on behalf of the SATURN project to the third SATURN webinar on international standardization and underwater acoustics. My name is Kathrin Kopke, and I work in the MaREI Center in UCC, and I'm just going to give you a quick overview and a very warm welcome also to our speakers. Just a quick throwback to the agenda that most of you have seen. So we have Michael Ainslie here from JASCO, Jong from TNO, Michelle Halverson from JASCO, and Stephen Robinson from the National Physical Laboratory in the UK. And we are hoping that after the talks, we have a bit of time for questions and answers, but please use the Q&A function in the meeting as well, so our speakers may be able to answer some of the questions already. I'm just going to give a quick context of the SATURN project. So SATURN started in February 2021, is a 4-year project, which means we're concluding next year. And I'm pointing this out as a lot of our resources are actually available on the SATURN website. The project brought together 20 partners from across Europe, and we're trying together to look into developing solutions to underwater radiated noise from shipping and other vessels. The team is very diverse. We have researchers in bioacoustics, experts from the shipping industry, engineers, science communicators, and many more. You can also connect with us on our social media, and we're hoping that you find something that interests you not only today, but also on the website. The webinar is part of a series that's actually led by our partners in JASCO. And originally we teamed up with DOSITS, which is a wonderful resource and brings a lot of other resources all around discovery of sound in the sea to wider audiences. So in May last year, we had a webinar on marine mammals and vessel noise with our colleagues from Aarhus University and the TU in Hanover. And the links are still available from the DOSIT websites and resources if you want to dive into those. We also had another webinar with Jong, who's here with us today as well, from TNO, and Johan Boschner from Marine, on more the technical aspects of underwater radiated noise from vessels, looking into sources, mitigations, and considering more technical aspects. And today we're concluding the series with this webinar. And yeah, we're very happy to have you all here and hope you're enjoying the session. And I'm going to hand over straight away to Michael to leave enough time for our speakers and unshare my screen. Okay, Michael, do you want to go ahead?
Yeah, I'm sharing my screen. You must.
It's great. Yeah, I can see it.
Wait a minute. I think that was the wrong button. No, maybe it was the right button.
No, it was right. Yeah.
It was the right button. Okay. There we are. Okay, you should now see my title slide.
It's perfect. Yes. Thank you.
Okay, so I shall be talking about standardization in underwater acoustics up until last year. And the reason for stopping last year is because I'll be leaving it to other presenters to talk about what's happened since then. I'll be, that long abbreviation there, ISO TC 43 SC3, that's the formal code for the Underwater Acoustics Sub-Committee within the International Organization for Standardization, ISO. My formal role in the project, in the SATURN project, is the work package lead for standardization. I won't actually be talking much about the project per se. I'll be talking more about the link with with ISO rather than within SATURN. So it's from an external perspective rather than an internal one from the project's point of view. I'll start with the slide explaining, why it's important, just generally, taking examples outside of acoustics, to produce and follow standards. Then I'll talk about a little bit about the ISO Technical Committee on Acoustics and the Underwater Acoustics Subcommittee. I'll say a few words about terminology, and then I have a final slide of did you knows. So this is the kind of a motivating slide. Why do we bother to standardize? Why do we need standards at all? And I'm going to show you two examples. The first one with a Swedish warship that was built in 1628. When it was built, the team shipbuilders there were two different teams of shipbuilders. One using what is now known as an Amsterdam foot, which is 11 inches long, and the other team using a Swedish foot, which is 12 inches long. As a result of this, one side of the ship was heavier than the other side, and so the ship was unbalanced. And when it first sailed in very calm weather, it sank in shallow water, literally so shallow that when it sank, the sailors that survived the accident were able to hold on to the top of the mast, and they were actually above water. The ones that were not able to hang on to the top of the mast went down with the ship, and they drowned. A more recent example is a flight from Montreal to Edmonton in Canada that was when the flight was fueled in Montreal. Instead of loading it with 22,000 kilograms of fuel, an error was made with the unit such that they ended up loading it with 22,000 pounds, as a result of which they only had half of the intended fuel load on board. And the result of that was that it ran out of fuel about halfway to Edmonton. There was no, when they ran out of fuel, there was no airport within their reach. But what they did find was a former Air Force base, and the pilot was actually able to glide the aircraft for 17 minutes. Fortunately for the passengers, it was an experienced glider pilot, and they landed the aircraft at the former Air Force base, which had been turned into a racing track, and there happened to be an event, a car race going on at the time when the emergency landing, and I can imagine that would have been some frightened people on the racetrack as they saw this huge aircraft approaching them. The event ended happily. There were no fatalities, but it does indicate the kind of things that can go wrong if you make a mistake with standards, if you don't follow standards. The Acoustics Technical Committee is this thing that we call TC43. It's chaired by Douglas Manville. The Secretariat is the German Standardization Institute. It was created many years ago, nearly 80 years ago. Its scope is basically standardization in all aspects of acoustics. And it has three subcommittees. The first is noise, second is building or architectural acoustics, and the third one, which is of interest today, is underwater acoustics. This is just to get a feel for the total number of standards produced here. And the important number there is 224. That's the total number of standards produced by TC43 in those nearly 80 years. By contrast, the subcommittee for underwater acoustics, which is SC3, was created in 2011. That's 13 years ago. Secretariat is also held by the German Standardization Institute, and it's chaired by Stephen Robinson, who you'll be hearing from later today. The scope is basically all of underwater acoustics, and it has 6 working groups. Now, I'm not going to go through all 6. I'm just going to just going to mention the first and the last. The other ones are less relevant today. The first one is measurement of underwater sound from ships, and you'll be hearing later from Chris de Jong about the work that's going on in that working group. The last one there is aquatic bioacoustics, and you'll be hearing from Michelle Halverson about that working group. And this is just to give a contrast to what you saw. Remember that number of 220 something for the total number of standards in acoustics generally? Well, there are 6, according to this, according to these statistics, there are 6 produced by underwater acoustics, by the subcommittee 3. And this is just a summary. of what I just said, highlighting the fact that TC43 SA3 is a very recent subcommittee by comparison with its parent committee, which explains why relatively few standards exist. So I'm now going to list, the previous slide said there were 6 standards. I actually only know of 4, and I don't know where the 6th comes from. So I'm going to list the 4 that I know of that were all developed in the 4-year period between 2016 and 2019. This work was started well before that. Okay, this work started in 2012, but this is when the first one was published in 2016. It's for the measurement of underwater radiated noise in deep water, and this is the title page from that one. The second one was published in 2017. That's this underwater standard terminology, and that's here's the title page for the terminology one. The third one was for pile driving, measurement of underwater sound from pile driving. That was published also in 2017, and the fourth one, published in 2019. Was also a second URN standard, and the difference is that the first one was radiated noise level, the second one is for source level, and Chris will be explaining all about source level and radiated noise level when he talks. I'm going to say a few words about what I call a terminology pyramid, and you'll understand what I mean by a pyramid as I go along, and it's best if I just talk. At the base of the pyramid is something called ISO/IEC 80000, and that's a series of fundamental standards, fundamental scientific standards, which I have had referred to as the Bible of ISO, and it really pins down fundamentals fundamental standards for mathematics, electromagnetism, mechanics. And of particular interest, for us at least, is acoustics, which is part 8 of that series. Then the next level up in the pyramid is ISO 18405, which is the international standard for underwater acoustical terminology. And based on 18405 is the SATURN terminology standard, which I'm calling here D2.3, which is just an abbreviation for deliverable 2.3. Some of you might be aware of this already, but SATURN produced a terminology standard, and it was built on ISO 18405, but expanding it so that it included vessel acoustics and bioacoustics as well. And you'll hear more about 23990 later from Michelle, but that's an ongoing standard that's currently in development that's also built on ISO 18405, will incorporate parts of the SATURN terminology standard, but will also incorporate terminology from elsewhere to produce an international standard for bioacoustical terminology. And now I'd like to show you an example, this time from the top down. It's the same pyramid, but we're starting at the top this time with a specific example of a term that will help you understand how it all fits together and how the pyramid actually works. So if I say cavitation noise, I think many of you will have an intuitive feel for what that implies, what it means. But you might be curious to learn how it's defined more formally, and that's what I'm going to go through now. So at the top of the pyramid is cavitation noise, which is defined as unwanted cavitation sound. Cavitation sound is defined as sound caused by cavitation. May sound trivial, but it's an important link in the chain. Then you have cavitation and sound, which are defined. The first term for cavitation is defined by the SATURN standard, as defined as written there as the process of formation of the vapor phase of a fluid when it's subjected to reduced pressure. And the word sound is defined by the Underwater Acoustics Standard ISO 18405 in terms of alterations in pressure. And then, this is now getting into the base of the pyramid, the word pressure is defined by part 4 of the ISO 80000, and pressure is defined in terms of a force normal to a surface, and the term force is also defined in part 4 of 80000 in terms of interactions between bodies or particles. So that shows how the definitions build on one another until they reach the top. which is actually the term that we're interested in defining. That's how the process terminology, how the pyramid works. That's my purpose here. This is my last slide, and I just wanted to give a few anecdotes that you might be interested in hearing. The first one is about the decibel. Now, anyone who's worked in underwater sound or acoustics generally will have heard of the decibel. What you might not realize is that although there was a formal definition of the decibel until 2019, the standard that defined the decibel was withdrawn in 2019, and since then, that unit has been undefined. The second one is to do with the word impulsive, which is defined differently in Europe as it is in the United States, such that a sonar pulse is considered an impulsive sound according to the European Union's Marine Strategy Framework Directive, whereas it's considered to be a non-impulsive sound according to the NOAA guidelines in the United States. And then the third one is that international standard 63 and 125 hertz frequency bands are not 1/3 of an octave wide, but 1/10 of a decade wide. And that concludes my talk.
Thank you, Michael. And you're right on time. So I'm going to hand over to Chris.
Yeah.
We can see your slide perfectly.
My slide is here. So hello. My name is Chris de Jong. I'm working at TNO in the Netherlands on acoustics for a long time already. And as said, I'm going to talk about standards for measuring the underwater radiated noise of ships. The abbreviation URN keeps popping up. It's part of the name of SATURN as well. So remember that. Why are we measuring ships? That's the first question, of course. And the main reason why we want to know the radiated noise of ships are various. A first one can be you want to know how much sound the ship is producing to compare it with some form of a contract, for example, a class notation or something like that. You also may want to manage the underwater sound produced by your ships, and that's something that's being discussed by the IMO, and it's part of the IMO strategy to manage your underwater radiated noise. And you have to measure it to know what you're doing. And then there's a lot of work going on impact studies where underwater radiated noise of ships is used as an input to create underwater sound maps, and also there you need data, so you need measurements. Well, measuring the underwater sound of a ship is the topic of this talk, and there are a lot of choices to be made on how to do these measurements, and because there are so many choices, it makes a lot of sense to make use of standards, so that if you measure something, you measure the same as everyone else is doing. First, I want to illustrate the amount of choices that you have to make. First of all, if you want to measure how much sound or underwater radiated noise a ship produces when it's sailing along, then you have to define at what condition of the ship you want to measure that, because it differs. If the ship changes speed, or if the draft of the ship is different because it has a different loading, or if it's maneuvering, all these have an influence on the amount of underwater radiated noise. So you have to decide for which of these cases you want to measure the underwater radiated noise. Then, the ship sends out sound in all kinds of directions, and you have to decide where am I going to measure? What do I want to know? You can't measure everywhere, so you have to look to things like the azimuthal and the depression angle, or sometimes people speak about beam aspect, that's looking to the ship from the sides, or keel aspect, that's looking through it from the bottom of the water. So it depends on where your hydrophone is and actually where you do this measurement. And the geometry is important, but also the environment in which you do this measurement. So the water depth and the sediment properties may have an effect on these measurements. So that's another choice. And then, what kind of metric what do you want to measure? Because the sound is quite a variable thing, and you have to define on what quantity you want to measure for the ship. And there the terms source level and radiated noise level that Michael already mentioned come into play, and I'll come back to that on the next slide. And as a last point is that, are you going to measure this ship with it knowing that it's going to be measured, with it cooperating, with it doing things that you want it to do, or are you just laying a hydrophone somewhere and measuring the ship that's passing? And that's the difference between cooperative ships and ships of opportunity. And for the second part, there are actually no standards yet. For the first part, there are some standards that I'm going to discuss. So first of all, this source level radiated noise level issue. The source level in underwater acoustics is defined as the sound pressure level that you measure somewhere far away from the ship in an environment, in an idealized environment, or that you measure somewhere far away from the ship, and that's affected by propagation loss in that environment. And if you correct for the propagation loss, you get a source level. It's something that has a direction, so it may be different in different directions, but it's a property of the ship, independent of the environment and the geometry. Actually, the direction may have an effect on the geometry, but it assumes that you're in an infinitely large space and that sound can freely travel in all directions. That kind of source level description of the ship is mainly relevant for modeling, as input for sound maps. Radiated noise level, on the other hand, is more related directly to what you measure when a ship is sailing. And one important aspect that's happening when the ship is sailing is that the sound is generated quite close to the water surface, and reflections at the water surface have an effect on how the sound is radiating. It creates an angle dependence in the radiation, and so it's what you measure on the ship depends on under which angle you look at this vessel. And if you define this environment, you can do a measurement, but then you have to define where you do it. And if you measure all ships under the same angle, you can compare their sound, and that's what you do when you measure radiated noise level. So these are two different things. Measuring ships is not new. It has been done for quite some time, but mainly in the defense field, in the naval field. And therefore, NATO has already for a long time standardized measurements of their ships. And there are two standard agreements in NATO that determine how to measure ships. And there are two particular standards. One that is for measuring ships related to torpedo and sonar detection threat. So mainly for sources that are at some horizontal distance from the ships. The other one is more related to mines on the seabed, and there it's important if the ship is above a mine. So you look at the ship from the bottom, from below, and these are different types of measurements. They also have a different procedure. Well, these standards are not directly applicable to the applications that we were looking for mapping, for example. So these different forms of radiated noise level produced by these standards were a start, but they were taken from the defense field into the commercial field, into the non-military field, by Ainslie, the American Standardization Organization, somewhere around 2009. Ainslie produced the first standards of how to measure ships, how to measure the underwater radiated sound from ships. And that's the quantity measured by this standard is called an affected source level, and it's actually related to the radiated noise level. But that term was only defined when this standard was taken from American only to the international field, and it was taken up by ISO, and a group in ISO worked on it and started working on the ISO 17208 series of measurement standards for ships. Radiated noise, and this series developed by the working group that Michael introduced has three parts now. The first two parts have been published. The first standard was published in 2016. A second part was published in 2019, and it allows to determine source level, while the first one was for radiated noise level. And the third part is yet at this moment under construction. They are all for ships that are cooperating. This whole process, you see how many years there are between the process between starting to work on a standard and finally publishing involves a number of steps where all the members or participants in ISO are allowed to vote in a ballot. And there's, after a new work item proposal, there's a committee draft, then a draft in the national standard, then a final draft. And with the third part, we are now in the stage of creating this final draft. Somewhere mid next year is the project limit date, so we have to hope to have the standard finished by that time. Such a standard contains a list of chapters, and it describes well the references that the standard is based on. It describes the terms that are being used. It gives general requirements of how to do these measurements for the environment to do it in, etc. It describes what configuration you have to take for the measurements, how to process the data to get the sound pressure level. Next, how to calculate source level or radiated noise level. And then it gives some instructions on, well, the uncertainty to be expected and how to report results. Well, these are all things that you need to take into account. All these details matter for standardization. The first part that's been published by ISO is a standard for measurement in deep water. It measures radiated noise level under a certain angle, and the angles are specified. It measures the ships while it's passing a hydrophone, as you see in the lower plot. And it measures as long as the ship is passing over an angle of about 60 degrees opening angle. Over this period, the sound is averaged. It uses a number of hydrophones in a vertical array, which observe the vessel on vertical angles from between 15 degrees and 45 degrees. So this radiated noise level is felt for these angles when looking at the ship. And it requires quite deep water. Oh, sorry, that was a bit too quick. Quite deep water. It must be 150 meters, or for bigger ships, 1.5 times the overall ship length. And you have to be about a ship length or 100 meters away from the ship to do these measurements. And then you measure the radiated noise level in the frequency range from 10 Hz to 20 kilohertz in decade bands. An example of such a measurement was carried out in the SATURN project by TSI. They measured the Spanish research vessel Ángeles Alvarinho, which is about 50 meters long. They measured it near the Canaries, and the figure to the bottom gives an example of a series of measurements according to the Part 1 standard, which shows the spectrum of the radiated noise level of this vessel. There is some variation because the run conditions were different. They were sailing in different directions at some slightly different conditions of the vessel. So there is some spread in the measurements, which illustrates how important it is to specify the conditions under which you measure the ship. And it also illustrates that what the standard takes into account is that you have to make a comparison with background noise. And in this case, all sound below 200 Hertz appear to be dominated by background noise. So this is not the noise from the ship, and that's something that has to be made clear in the reporting. So that's done in this fashion. Well, that's an example of how a standard measurement of radiated noise level is. If you want to use this for modeling, you need source level. And therefore, the second part of ISO standards provide a procedure to convert this radiated noise level to source level. And the difference is adding a formula, or actually a correction to the measured radiated noise level. And this correction depends on the source depth. So the source level is also only valid if you specify the source depth at which it is defined. And the standard is clear. It says the source depth has to be nominally at 0.7 times the ship's draft. So the source level is valid for that source depth. The correction accounts for the surface reflections, which lead to a decrease of the radiated sound at low frequencies, because the sound waves cancel at the water surface, and the correction corrects for this effect. It provides a curve that approximates the difference between the two, and it gives you an insight in what the actual source level is. And again, this was applied to the measurements by TSI. The plot now shows the radiated noise level that I showed previously. And if you go to the source level, the levels at low frequencies, in this case mainly dominated by background noise, increase a bit, and the levels at high frequencies decrease a bit, and then it's source level what's in this plot. And this can be used in sound maps. Well, that's all very nice, but as said, you need quite deep water for measuring ships, according to this standard, and that's a practical limitation for many applications, because if you have to take your ship to an environment where the water is 150 meters deep, or 500 meters if you have a ship of 300 meter length, that has a large impact on feasibility and cost of these measurements. So there was a clear demand for a more flexible measurement procedure. And that's why we're working now on ISO Part 3. And that's more complicated because in this case, the sediment and the water depth waves reflecting at the sediment play a role, and you have to correct for these in some manner. Well, this is work in progress, so I can only show where we are now. The standard is calculating the source level of the ship, again at the same nominal depth as for the deep water procedure. We've tried to make it not only possible to do measurements in shallow water, but also to offer some more flexibility in the measurement geometry. So instead of limiting the distance for the measurements to the real ship length and 100 meter, there's now a requirement that you can get a bit closer if you know that the source of the ship is, for example, mainly the propeller. Then the effective length of the sword is shorter than the total length of the ship. You can get closer, and there are some limitations on how close you can get, which are specified in the standard. The water depth that you can do the measurements is somewhat dependent on ship length and speed, and the standard provides tables for that, or formulas to calculate that. And it allows for vertical or horizontal hydrophone arrays, which I'll illustrate on the next slide. And there's an option then, if once you have the source level, to go back to something to the radiated noise level, so that you can compare your output with the first part of the standard. Well, some idea of the flexibility. If you're able to get your measurements closer than the actual water depth, then you're back to the deep water standard, so you can use the same geometry. If not, if your measurements distance, the deep CPA is far greater than the water depth, then you have an option to choose between either a vertical array of 3 hydrophones or a horizontal array of 3 hydrophones, or even 1 hydrophone with some loss in certainty, so increased uncertainty in results. So that gives an idea of what is described there. You do a measurement of sound pressure level, and you add propagation loss to calculate source level. And the standard, the draft international standard, provides now a formula which is called the seabed critical angle formula. I'm not going to explain the details of this, but this is a correction or a formula for the propagation loss, which is based on the angles under which you're observing the vessel. The seabed properties are quantified in terms of the seabed critical angle, and then there's some geometry and frequency parameters in there, and well, with that formula you can calculate the measured sound pressure level to a source level. And again, this was tested in the SATURN project, where we are using the same vessel in water depths that were somewhat more shallow. The figure to the right here compares the deep water measurements, so the black line, to measurements done in two different water depths, indicating that, well, at the highest peaks, the measurement in shallow water is quite close to the deep water standard. At higher frequencies, it's also still quite close. It's 2 or 3 dB below it, but it's somewhat underestimating what's being measured in deep water. And that's something we're working on at the moment and I think we have found a solution to modify the formula to correct for part of this difference, and that will be part of but it will be proposed as part for a new standard, which we are going to discuss later next month. So that's giving you some insight in where we are with the development on the standard. So what you need to realize, you can't just go out to measure a ship. You have to make a lot of choices, and the details matter. So and the ISO standards provide you with guidance to make these choices, which is relevant to do so. And we are working hard towards a final draft international standard, which will be then out for ballot. And you may expect something to be published by next year. And that concludes my part. Thank you.
Thank you, Chris. That was great. And I also want to just put people's attention to the chat. Orla put a link to one of the reports that Chris referenced in his slides. And there's more on the website as well. I'm very happy to introduce Michelle Halverson from JASCO with the next talk.
Sorry, I needed to unmute. Can you see my slides okay?
Yes,
Yes.
perfect.
Thank you. So I'm Michelle Halverson, and Chris, that was an excellent overview on what you guys are, the progress you guys are making. I'm shifting gears to talk about standardization in underwater bioacoustics. So it's still related, but it's a little different niche. Why is this not? There we go. Okay, so aquatic bioacoustics is my focus today. Michael started off talking about the ISO Technical Committee 43, Subcommittee 3, which is chaired by Stephen Robinson, and he'll be talking after me. And I'm the sixth working group here is aquatic bioacoustics. So Chris just talked about working group 1. Working group 6, aquatic bioacoustics, I'm the convener, and we have about 20 members. I shouldn't say about, we have 20 members across these 8 countries. And our group, the working group 6, became official about November 2023. And I say that to indicate that we're a young group and trying to make some strides. So the working group 6 as a whole has a scope, and that is, this is what's included under it. And I'll just read this out loud. It's standardization in the fields of underwater bioacoustics and biotermology, including sound production by aquatic life. Aquatic life means all life forms that use aquatic habitats. Reception of sound by aquatic life, effects of sounds on aquatic life, gathering of sound by aquatic life, and the passive and active acoustic monitoring of aquatic life. So anything in there could be something within the working group 6. And our first project is bioacoustical terminology. And that is being led by Michael Ainslie. And it's founded on the SATURN terminology standard, D2.3. If you remember, Michael showed that in his pyramid, and I'll swing it back in a couple slides. The principles of working group 6, specifically for 23990, is that these definitions, the terminology that comes out of this work product, out of this standard, will be self-consistent. They'll be compliant with ISO 8000. And if you remember, that was the foundation for, it's a foundation piece in the earlier talk. And then definitions will be compliant also with 18405, which is underwater acoustics standard. And we will also be consistent with the use of the terms across the related branches, biology, physics, and engineering. As we know, we can use different terms to mean the same thing or any variation. So the process for developing 23990 is we got our group of experts are built together. So that's the working group 6 members. And then the foundation is the SATURN terminology standard. And you can see I'm using the same pyramid again and showing standard terminology standard as our basis for building up to the 23990. I'll go into this in more detail in a minute. I have a slide for each of these. So we'll review the SATURN standard. Working group 6 did a review of the SATURN standard. Working group 6 filled out a questionnaire, and with it returned over 150 suggested terms. And other sources of terms were also brought in to help build up the 23990, and that is the Dictionary of Acoustics and glossary terms from docets. And I've included the links for those sites down here just if you wanted them. So I want to start off with the terminology standard. the SATURN terminology standard. And this is the, on the left is the title page, and you can see there's several authors, and I have the link there at the bottom to this standard. So it's EU funded program, as we know. There's 10 authors, and this was also led by Michael Ainslie. And this task occurred from February 2021 to June 2024. And so it's hot off the press. And this has been then brought into as the, as the foundation for the development of 23990. This standard, the SATURN standard, included bioacoustics, vessel acoustics, and sound mapping. And so the bioacoustics is why it was a big part of it. It is our foundation. So these are the tables. And I said that there was a questionnaire given to Working Group 6 members. And all of the terms from this report were put into tables. And so those tables were then reviewed in the questionnaire. And this is just a quick snapshot of what the questionnaire looked like. It was very brief. And the idea was to just give directions, limit the review to the tables only within that report, ignore the vessel acoustics because that's not part of the bioacoustic terminology, and to stick with the bioacoustics and sound mapping. And so, as I mentioned, we received a lot of terms. And this is just to give you, I'm not going over any of this. It's just let your eyes scan around. You can see there's a broad breadth of terms that came in from that effort. And so I'm bringing us back to this pyramid to re-explain this a little bit more. So this process has resulted in about 283 new terms within now the 23990 working draft. And that is based on SATURN terminology standard, which is down here at the base of our pyramid. Docent's glossary terms, the Dictionary of Acoustics by MaREI, the efforts, and this is the review, the bringing all of this together will create our pinnacle of 23990. So our timeline for this is next. And Chris talked about this with his section already under some of his standards that are getting close. So I don't know, I think it's good to hear how these processes go because it seems kind of mysterious on the outside looking in, I think. So for the terminology standard, I apologize. As I mentioned, this group started in November of 2023. We have our first working draft, which has 283 terms in it. We're aiming to get a committee draft submitted in November 2024, so just in a couple months. The working draft is going to be talked about at our next meeting, the 4th meeting for the Working Group 6. So in these few months, we've had 3 and about to enter into our 4th meeting. We'll get comments back from that committee draft in about February, and then we have to address those with the working group and submit a draft international standard that takes about another 4 or 5-ish months for us to get that turned around. And that goes for a ballot, the draft international standard. And at that point, we would get results back from that about December next year. And then it would move into the next steps. So final publication of about October 2026. The other thing that's involved so we have Working Group 6. Our first project is 23990, and I've kind of walked through the process. that we've gone through so far, and to get us to the point we are now. And also within Working Group 6, we can take on new projects. And a potential new project, there's a preliminary work item. And what that means is there is the potential for a new project under Working Group 6, which should be on the topic of particle motion. And it has a foundational document already, and I have a link for it down here, and it is the best practice guide for underwater particle motion measurements for biological applications, and that's published by Nedlick et al. In 2021. And then an example topic that would relate to particle motion is a analysis that was done by Bruce Martin. And I'm here, just pay attention to the words in blue. He replotted the Wentz curves to show the range of particle motion spectral densities. So this top graph is showing the sound pressure, and the bottom graph is showing acceleration. And I chose acceleration. He also did this in displacement and velocity as well. I chose acceleration because the best practice guide from Nedlick 2021 recommends we report acceleration. So that is shown here. And the only thing I really want to point out about the differences between these two is I just put a pink line of there's a decline, across frequencies for the pressure, but it's pretty flat across frequencies when you're talking about acceleration. So what does that mean is a discussion for another time. This would feed into that project, though, essentially. And I mentioned real quickly, I guess this is the next step, but we have a 4th meeting for the ISO working group coming up, and that is happening in October. It's part of the ISO plenary meeting that occurs in Berlin. And I'm not sure if Stephen's going to talk about that, but anyway, we will be discussing, our working group will be meeting there and discussing the next steps and finalizing that working draft to submit our committee. And so if you're interested in getting involved, please stick around and listen to Stephen Robinson, because I think he'll go into that a little bit more. Thank you.
Thank you, Michelle. That was great. Just want to put people's attention to the Q&A and the chat. So there's some resources, more resources shared, and also some comments and some questions have been put in. And last but not least, big welcome to Stephen Robinson talking about the future. Where is this going on?
Okay, hello everyone. Can you hear me and see the slide?
Yes, it's not in presentation mode yet, but we can hear you perfect.
Hold on a second. Let's see if I can find the presentation mode for you. It's not in presentation mode. It is on my screen. Let me just set the display setting. Hold on.
Oh yeah, sometimes you have to switch it around, right?
Is that better?
Yes, that's perfect. Thank you.
Okay, so I'm just going to say a few words about future and some current developments in standards. Before I started, I wanted to say something about the different kinds of standards, organizations and committees that you hear about. There are basically 2. There are actually more than that, but only 2 that are relevant here. One is ISO, and they produce standards for measurements and specifications of different kinds of things, but including acoustics. And TC43, as Michael's already said, covers acoustics, and TC43 Subcommittee 3 covers underwater acoustics. There's also another committee, also based in Geneva, called the International Electrotechnical Committee. And IEC produced standards for electrical technology, and that includes electroacoustics. And so that includes things like technologies like microphones or hydrophones and so on. TC87, Working Group 15, produces standards that cover the calibration of electroacoustic devices for underwater acoustics. And I'll tell you a little bit more about their work in a second. That includes things like hydrophones and other kinds of sensors. And just to say something about this word standard, What ISO and IEC produce are written specification standards describing, for example, how to do a task, how to measure something. They're usually written procedures or written specifications. These are, the word standard in English is used for a number of meanings, and so ISO and IEC do not produce metrology standards such as realizations of primary units and so forth. So when someone says my measurement's traceable to some standard or benchmark, that's not the kind of standard that we're talking about here. We're talking about written documents, and they're not regulations either. So they can be cited by regulation though, and which can require their use. So taking an example from air acoustics, the the EU noise directive, machinery noise directive can set what the levels must be for machinery noise and state that all white goods, refrigerators or whatever sold into the community must have statements of the sound power that's radiated. And they will state levels, but they will also cite which ISO standards which describe how those things are to be measured. So they don't set the exposure levels, they don't set the regulation, but they do tell you how to measure the things you need to measure in order to satisfy those regulations. Okay, so I won't say much about this because Michael's already covered it, but I'm going to say a little bit more about what, filling in some of the gaps. So what's going on in Working Group 3 and 5, because we've heard about what's happened in 1 and 6 already. Just to say though, before we move on to Working Group 3, a little shout out for SATURN. You probably realised from what you've heard so far that SATURN has contributed a lot to the work in Working Group 1 and Working Group 6, in particular the ship noise standard that Chris de Jong has described, and the one that Michelle has just described is just starting on the terminology of a bioacoustic. So it's great credit to this project, of which I am not a part, I should say, that the outputs of the project are feeding into these standards. So Working Group 3, what's going on in that part of the committee? So this covers standards for marine pile driving. Marine pile driving is a method of construction used in the ocean, particularly for things like oil and gas platforms, bridge foundations, but in particular for offshore wind farms. We've already had a standard from this group on how to measure the sound radiated during this construction technique. And this particular one, 7447, covers a description of how to test noise abatement technologies for marine pile driving. These consist of anything from sleeves or bubble curtains, which are designed to attenuate the sound radiated from this particular source of impulsive sound. And you can see some pictures of some of these types of technology on the slide. This has just been published literally this month. So this is one of the missing standards that Michael talked about earlier when he said he couldn't find all 6 standards that this subcommittee's produced. This is the latest one. Working Group 5 covers the measurement of underwater ambient sound in the ocean. So this is again procedures for measuring ambient sound. This covers everything from terminology right through to equipment, deployment, data analysis and reporting. And it builds on the outputs of other recent research projects. So for example, a couple of EU projects, in particular JOMOPANS, and also a US project called ADION. This has reached quite an advanced stage. So the so-called FDIS, which is the final draft, is due after the Berlin meeting that we have in November. And so the likely publication date for this is mid-2025. Now, this slide just shows a few examples of potential future work, again, in this ISO TC43 SC3 committee. So Michelle has also already mentioned that measurement of sound particle motion might be a new item of work for this committee. This has been led by interest from the UK, from Sophie Nedelec, a researcher at Exeter University, who led the work to produce the Good Practice Guide, which you can see an image of in the top right, on measuring particle motion. So building on the work that's done there, we're now hopefully going to start turning that into an international standard, beginning, we hope, after the meeting in Berlin next month. Some other examples of possible future work, which are, if you like, on our wish list at the moment, measuring explosive sources, in particular in Europe, things like clearance of UXO, that's unexploded ordnance that lies on the seabed, can be extremely loud, impulsive sources of sound. And this builds on preliminary work done in the UK, where we've already produced a sort of good practice guide, which has been adopted. Again, it's quite limited to UXO only, but we can certainly build on that, hopefully, and produce an international standard, which perhaps is broader in scope. On ships of opportunity, measuring those, well, here we're talking building on work from existing projects again, such as the ECHO project and so on, and possibly from SATURN also. We're talking here about measuring ships that are in transit, using some kind of semi-permanent static measuring station. So here, unlike with part 3 of 17208 that Chris so comprehensively described, we've not got control of the ship. There's no cooperation from the ship. It's just in transit going past. The advantage here would be you could get many more data sets of ships out of this, because obviously not so many ships are likely to allow you to spend the time measuring them while you have control of their activity. The difficulties here are that you are also contaminated by other ships in the area, so that makes it quite a challenge to make an accurate measurement. And there are a couple of other items, calibration of echo standards, which is currently going on in Working Group 4, and a potential for starting some work soon in vibropile driving measuring in Working Group 3. So then moving on to this IEC committee that I mentioned, the International Electrotechnical Committee. The relevant committee here for underwater acoustics is TC87, that's Working Group 15. Which covers the calibration of underwater electroacoustic devices. And so they have produced a number of standards over the years, and I'm the convener of that standard, so there's quite a close relationship between this working group and the TC43 in ISO. It covers properties of hydrophones, calibration of hydrophones. The two parts go from frequencies below 1 Hertz right the way to above 1 megahertz. And the latest one, just published this year in April, is calibration of vector sensors. Acoustic vector sensors include sound particle motion sensors, such as the ones that might be used to measure sound particle motion in the ocean using that good practice guide we heard about earlier. And there's even an international electrotechnical vocabulary, the IEV, which covers terminology. And part of the work we undertook was to update that to try and make it more accurately reflect the recent developments in things like ISO 18405 and others, and ISO 80000, which had come more recently, and that was a particularly old standard which we updated in 2021. The latest item, which will be starting soon, is calibration of digital systems, digital recorders and hydrophones, for which there currently is no international standard. Finally, the final two committees I wanted to mention are two committees that don't really focus on acoustics specifically, but have work items which are relevant to acoustics. So the first of these is IEC TC25 and ISO TC12, both of which share responsibility for this series of standards called ISO 80000. Part 8 of this covers acoustics, and Michael's already mentioned this, and that was published in 2020. Michael, in fact, led the work to revise that standard. And there's also, as Michael hinted at, the decibel was defined in a different part of these standards in part 3, but when part 3 was updated and revised in 2019, that part of the standard was omitted, the idea being that all logarithmic and related quantities would have their own standard, which is part 15. And so part 15 the development of part 15 has begun to cover not only the decibel, which is used in acoustics and electrical engineering quite extensively, but also the NEPA, which is used a lot in physics generally, and things like frequency bands, which are fairly much peculiar to acoustics, things like the octave and fractional octaves and so forth. So work started on this some time ago, but was interrupted. And so it's restarted recently with myself, Michael, and another colleague of ours from Air Acoustics, working on the redrafting of that, and publications likely towards the end of next year. Finally, the other committee I wanted to mention was a committee that doesn't really deal with acoustics at all. Generally, it's a committee dealing with the Internet of Things. So that's the interconnectivity of things like sensor networks and communication networks. They do have a series of standards they produced in this Internet of Things committee. The ISO 30140 covers underwater sensor networks. And that's mainly concerned with protocols for communication, acoustic communication between different sensor nodes and so forth. But the people in this working group are quite enlightened in their view of worries about noise exposure for marine life. And they've realized that some of these communication systems can pose noise exposure worries for marine life, and they've started to work on a technical report. It's a different kind of output from an international standard committee. It sort of doesn't have the status of an international standard, but it's a kind of precursor to it. They're working on a technical report which will describe how the exposure assessment should be done, and they're pretty much using what the sort of practical methodologies that most people use, separating it into source, propagation, receptor, threshold levels, impact, and so forth. And the technical lead for that, Patrick Miller from St Andrews University, and there's a joint liaison with Working Group 6, the one that Michelle has just described, to provide some input into the process there. So for just final thoughts then on standardization, you'll have perhaps realized from what I've said and what some of the other speakers have said that quite a lot of the standards work builds on existing research projects, the outputs of those projects. That's either because the projects themselves are enlightened enough that they think standards are important and worth developing, but it can also be for quite a selfish reason. If you're developing a project and you want to demonstrate the increased impact or establish a legacy for your project, then having a work package or some work or activity on your project to feed into international standards can be a very useful goal. And we're very lucky that some of the projects, some of the ISO work we've got has fed directly from some of these projects that we mentioned, such as the ship noise 17208 part 3, feeding from projects in Canada, such as ECHO, and the SATURN project we're talking about here. I mentioned that 7447 was led by Germany, and that fed on work produced in Germany to produce their own standard for this, and we built on that. And 7605, the ambient sounds standard, builds on both EU and US projects, which develop their own measurement protocols, which are a start for building into an international standard. So if any of you listening or attending are interested in participating, perhaps inspired by what you've heard from the outputs of the SATURN project, the question might be how you might do that. Well, there is a certain formality to it. We're always looking for good expertise and new voices to be heard. But in order to participate formally, you need to do it through your own national body. So, for example, in the UK, it would be BSI, in the USA, it's Ainslie, DIN in Germany, AFNOR in France, and so forth. Volunteers, therefore, need to approach the relevant national body in the country of origin. If you don't know how to do that, you can always contact me for information, or your own national body's contact person, for example, in BSI, ANSI, and so on. If you're wondering how much effort that might take, well, the degree of involvement can vary. You can be actively drafting standards and leading the work the way that Michelle, Michael, and Chris have described for their working groups. And often, if you're developing a standard that comes out of your own project that you worked on, perhaps you want to steer the work in a particular direction. You want active involvement, or maybe there's some funding to do so within your project. If you can't afford that time, you can simply be a member of the working group and comment on the working drafts. And even more, less active, you can just be a member of the national committee, which is the mirror committee to these international standards, which will still get to see the draft documents when they're circulated and still be able to make comments. So I would encourage you, if you're listening to this webinar on standardization, to get involved if you're interested, and you can contact me or any one of the speakers here who'll be able to help you do that if you're interested. Okay, that's all I have to say.
Thank you, Stephen. That was great. So yes, please, anybody interested, anybody with a project and work, do get involved, contact people. We're here to help connect you. There wasn't as many questions and some comments, but I just wanted to put this forward to people. So upcoming work for some listeners here. Do you have a list of equipment used in the deliverable reports? As there will be very soon some measurements being run for smaller fishing boats before and after electrification. And Mert would like to know or get an idea. Anybody of the speakers that be able to answer this query? Chris,
I believe
I can see you nodding.
Yeah, I believe that most of the information is in the SATURN report that was already a link provided in the chat. Roberto is online, I see, so if we can give him the opportunity to speak, he can perhaps answer this question.
You try and find Roberto. There's a couple of people there, but
Roberto
you could try.
Jubero, yeah.
Yes, I know.
Yeah.
I saw him register. Yes, I have him. Oops. So I hope Roberto is not taking a break now.
No, I'm here. I'm here.
Okay. Would you like to speak to that? Yes.
Yeah, sure. Can you rephrase the question? What's about the instrumentation we used? Yeah.
It's
Is there a list of equipment, Roberto?
Yeah.
Yeah, there's a section in the report.
Used.
Yeah, there's a section in the report that explains what equipment we use and specifies the precise models and yeah. So there you can find a detailed description, and if you need further information, my email is there in the report, and they can email me to answer anything else.
Yeah, that's maybe also good to point out. If you get the reports, they're on the SATURN website in the resources and results section, and there is contact details for everybody involved, so you can get to the people. I think all the other questions were addressed or comments, as far as I know, unless somebody, I think, yes. I might have a question for Michael if he's here.
Michael is here.
Yes. Michael is here. Okay. Concerning your last slide, if the international standard frequency bands are 1/10 of a decade wide, why are they called 1/3 octave bands? Is this a mistake?
Right. No, it's not. It's not a mistake. It's really a reference to what they used to be, and by that I mean 10 years ago, the international standards for frequency bands specified that one could choose between a 1/3 octave band and a 1/10 decade band. Today, that's no longer the case. 10 years ago, the international standard was changed such that only 1/10 decade band is now permitted if you want to comply with an international standard. So referring to 1/3 octave is actually just a lazy way of saying 1/10 decade, and this is why you have consistently heard today 1/10 decade or decadecade and not 1/3 octave. The wording is still used by the European Union MSFD, and I think it would help resolve the confusion if the European Union stopped using the term 1/3 octave, because they're not.
Okay, I would agree on that because it is a bit confusing. Okay. Are there any more questions? Do people want to put more in the Q&A? I'm very impressed with the speakers today. Everybody kept the time. We actually have a lot of time. I was a bit nervous because I know when you explain these rather complicated parts, and I think everything went really well, but people can tell us afterwards. What we're also planning to do is we're trying to look at the recording and hoping to share this on the website if maybe some of your colleagues weren't able to attend or to look at things back. And I would also ask the presenters, can we share your presentations from the SATURN website so that people can have a look as PDFs? Okay. Been very clear. I might have more questions, but I have to think about it. So maybe it was also a lot of information for some people like me, who's not intricately involved in the standardization world. That's why also we want to make it available on the website. So if people do not have burning questions, and unless any of the speakers want to say more, there is something. And oops. Oh yes, I agree. Yes, there would be more work to be done for people to dig a bit deeper, because of course these reports are just thrown at some of the audience members. So yeah, please check it out, the website and everything. There's been a lot of work put into this, and you know, are people happy to close the meeting? I'm gonna ask Michelle, as the lead of the webinar series. Will we conclude our last?
Seems quiet to me. I'm okay with that.
Yes.
Yeah, if you're asking me, fine by me.
Yes. Okay. No, so I want to thank everybody that attended and listened to us. And we had a steady number of people. You didn't lose people, as in many people. So that's reassuring. So it's obviously of interest. But I would also think that was a lot of detailed information and a lot of resources people might need to look into. So I expect listeners to contact you. And yeah, there's also thank you for this. So people are happy for the excellent speakers. So that goes to you. And with that, I will conclude the meeting.